Okay, so how do we compare different items that are being measured on different scales? In this particular case, we have employees taking an aptitude test. We have three different scores, but the three tests have different means and standard deviations. So we want to put them on a single scale. In other words, we want to standardize it. So standard scores are also known as z-scores. And let's click on this here. The formula for z is x minus the mean over the standard deviation. So for Justin's z, we have 92. X is his raw score minus the mean, 72.8, divided by 12. And that'll give us a z-score of, let's try that in a calculator here real quick. And let's divide that by 12. So we'll get about 1.6 for Justin. And what does that mean? That means Justin scored 1.6 standard deviations above the mean. Cade's z would be 302.4 minus 243 over 27. Let me go ahead and work these out, and then let's talk about the results. Okay, this is what, if I did all my calculations right here, this is what we ended up with. So basically, Justin was 1.6 standard deviations above the mean, Cade was 2.2 above, and Caitlin was 1.9. If it's positive, it's always above the mean. Negative z-score is always below the mean. Z-score is how many standard deviations are you above the mean. So in this case, now that we've put them on a similar scale, their original scores, don't pay any attention to them. Okay, Cade in this case did have the highest original score and he had the highest z-score, but that certainly doesn't have to be true. You could just as easily, for example, if Justin had gotten a score of, say, 120, he would now be well above Cade in terms of his z-score. So at this point, you're just looking at the z-scores because now they're comparing apples to apples. You're on the exact same scale. So we can say that Cade did the best relative to the peers, and Justin did the worst. Even though Justin's raw score was higher than Caitlin's, once you put it on a standardized score, a standardized way of measuring, Cade's score would be the highest, and Justin's score would be the lowest.